So, Tim, I thought you might enjoy this little project I'm working on. I rebuilt the engine in my '08 Silverado 1500 5.3. It's the fourth generation um, LS engine. So this was the beginning of the displacement on demand. So I went in and pulled out the lifters that go with changing it from 8-cylinder to 4-cylinder, and the cam I put back in is a higher lift cam, a little more duration, not much. You can't even really call it a stage 1. But I was going in and looking at the tune. So this is HP Tuners, and this is the VCM scanner program that collects all the data when you're driving around. So I went out. This is a recording of going out, run it from 0 to 60 full throttle on a country road out west of town. And the first part is kind of uphill, so it's a little bit of a pull. And then the third one I did down here at the bottom scale, right down here. That's like the first one, second one, third one. So this one's a little flatter. And go in and, so this VCM scanner is just a program you get, plug it into your OBD port, and it reads all the data and puts it, on this kind of format or layout. There's a little graphical one up here. It's got the speed, and down here down on the bottom bar is the whole scan. And what I did is I went around and I did it again. I did 3 more 0 to 60 pulls on that road with the tow haul mode turned on. So as you move this thing along here, of course, all the data then goes with it. So up here you got a gauge, speed, RPM. Then you got the same information down here, graphed. Down here I got RPM, speed, injector duty. I don't know why the temperature, I don't know, ECT, I don't know what that is on the first graph. And then down here you got long-term fuel trim, short-term fuel trim for bank 1 and bank 2, since it's a V8. And above it is the O2 sensors. So this thing uses 2 things. Uses the mass airflow MAF meter that's on the inlet to the into the intake manifold to measure the air intake. Then it calculates based on that much air, measured air. It adds enough fuel to try and reach stoichiometric air-fuel ratio. And then that's just an ongoing calculation. And then based on the O2 sensor, it's a narrow band O2 sensor here. And if the O2 sensor is high, that means it's running a little bit of rich right there. So it's running, O2 sensors are running 800 millivolts. And it's running high, and after it runs high a little while, then the fuel trims start to come down, and I'll drag this from as it comes along there. You can see the fuel trims start to go down, and well, the right hand side hasn't started down yet, but left hand side, the bank 1 has already started down. And then bank 2 has started down -3%. So it's pulling It's running rich, so it's pulling a little bit of fuel. It's reducing the fuel like up to 4%. Once it gets to there, then the O2 sensor starts to go down. When the O2 sensor comes down, then it starts to put fuel back in. It's running lean. It's adding 7, 8, 9%. Well, the camshaft I put in changed this all a little bit, and I wish I had done this before I put in the camshaft, but I didn't. So up here are the fuel trims at engine RPM is the x-axis, and the y-axis is a manifold absolute pressure. So this upper left-hand corner is idling, and then as you run the throttle up, the manifold pressure starts to increase because it's a vacuum, right? It's running on a vacuum, so the vacuum, that's always got me. The manifold pressure is if you think of absolute pressure, then it's low absolute pressure at idle. It's high vacuum, low absolute pressure. And then as you open the throttle, the manifold pressure starts to increase, the vacuum starts to decrease. Till you're down here, wide open throttle down here, and then of course you're starting to accelerate under wide open throttle, and it travels up to here because your RPM is coming up to 4,000, 5,000 RPM. Looks like I maxed out at 5,600 RPM. Then if you get off the throttle while the engine's still high RPM, then of course your manifold pressure drops way down. So this is like deaccelerating up here. The problem is with this cam, it appears all my fuel trims are really high, like 12%, 13%. And then if that's long-term fuel trim, short-term fuel trim is on top of the long-term fuel trim. Eventually, if you drive enough, the short-term fuel, it's making these adjustments before you even get to the short-term fuel trim. The short-term fuel trim is controlled by this O2 sensors, and the long-term fuel trims, I believe, are applied to the amount of air that's coming through the MAF. Anyway, they say that these should be like less than 10%. Well, mine are way more than 10%, and they're kind of low down here at lower speeds, and they're way high, positive at higher speeds. So what I did was I went into the program then. So we'll click down here on the wrench. See the wrench bar there? So this is the HP Tuners VCM editor. So you can edit the program. And I'm going to open the most recent file that I have that I've loaded onto the computer. And there's all these different set points. It's just super complex, so I've been slowly getting at it on the airflow. One thing it has on the airflow is it has airflow versus frequency. So actually what the mass airflow sensor is a hot wire that vibrates when air flows through it. Of course, the frequency of the hot wire changes as the air mass flow increases. So this is simply a chart from the factory that says what the airflow is, but the airflow is coming in. This airflow sensor is right after the filter, right after the air filter. Of course, then you got a long piece of plastic pipe and your intake manifold. And then your intake runners right up to the intake valve. and all that's kind of dynamic. So apparently mine isn't very tuned, so I've been working on tuning this, increasing, decreasing it, in order to get it to run with fuel trims that are a little bit lower. So what we'll do is we'll go over and I'll open up this one. This is the most recent one. Drove down to Salem yesterday to visit the kids for a birthday party. Actually, we missed Easter celebration down at Chris's because she was in the hospital getting a kidney stone busted up and removed from her. That was stuck in one of her ureter tubes. So anyway, she's feeling a lot better, and we went down there for, can you believe it? My oldest grandboy turned 16 yesterday. Ryan turned 16. Wow. So anyway, this one is a little bit closer, driving down to Salem. Oh, I'm gonna go down here and drag this thing. Oh, make it a little bigger. I'm gonna drag it up. This is like driving. It's kind of amazing. This is RPM, up, down, up, down. This is just driving, and finally I get over on the highway heading down to Salem, and this is under cruise control. So RPM speed is at 60, RPM is 1516 RPM, and it just stays. The cruise control does a pretty good job. And down here, if you look at this whole time, the mass airflow is here. Accelerator pedal is 0, but throttle position is at 34. It's because when you put it on cruise control, the accelerator pedal goes to nothing. And I thought I had mass airflow right here, 4.24 pounds per minute. Another thing I added to this chart up here, a couple parameters, is I added this what did I do? I think I just leaned on my keyboard here doing this. Open this back up. Anyway, I was going to point out down here. So I'm going along on cruise control, and then you come along and you hit this stuff. You hit some of this bumpier stuff here. Well, what happens is I'm going along on cruise control, and I come up on traffic or a curve or something, and I kick the cruise control off. I turn it, I just turn it off. So going along on cruise, the O2 down here, the O2 sensors are trimming fuel. O2 sensor goes up rich, and then the fuel trim comes down, takes a little bit out. O2 sensor goes down lean, and the fuel trim injectors are commanded to go up a little bit, up positive. And it just plays pong between these this narrow band O2 sensors. This play pong, when they go up, they pull a little bit of fuel. When they go down, they add a little bit of fuel. And then the trick is then, come on, put my keyboard out of the way here. more boring than what you care to. I find it pretty interesting, so maybe you've given up on me already. If not, just going to point out in this spot right here. So the going along here, and I think my speed is like set, cruise control set at 59, cruising along, and then I kick the cruise control off. One of these spots in here. Scroll in. So when I kick the cruise control off, the accelerator backs off. Can't find it now. Anyway, I found that pretty interesting. So back to this whole chart here, still running a little. I mean, it's most of it's under 10. I'm a little bit over here, and so I made another chart. It's not showing up on my desktop here. That shows it shows this fuel trim, long-term fuel trim, on a graph when compared to this frequency, this airflow frequency. And so all I do is go in, and on this airflow, which is in pounds per hour, at the frequencies where the fuel trim is high, let's say 10% high, I'll add 10% to these airflows, and where it's maybe 10% low, I'll remove 10%. And I've done that calibration, so I'm hoping the next time I take this thing out and run it, that this table here will be populated with all numbers that are like plus or minus 5%. So anyway, just enjoy playing with this thing, and I just, man, the programming that's in this computer is kind of amazing, but it's not really controlling that many things, you know. It's controlling the injectors, trying to pump enough gas in to reach stoichiometric as you're driving along. So it's kind of cool. So